As we start to look a little closer at the cleaning of watch parts, the one thing heard over and over is not to use IPA alcohol at any time on parts with shellac jewels like the pallet fork or the safety roller on the balance. When servicing a movement, sometimes it's more important to know what not to do than it is to know what you should be doing, because the last thing you want is to create a problem that wasn't there before you started to service the movement. Well, today we're going to put that to the test by not only soaking shellac pallet forks to see how much exposure to IPA they can take before failure, but we're also going to test vintage pallet forks by running them through not only an ultrasonic cleaner, but also a basket machine using professional grade cleaners to see how they hold up. By the end of this video, you will know for sure how much exposure shellac can take in your cleaning routine, and you will see whether it's safe or not to put a vintage pallet fork in a cleaning machine, and this knowledge will make you a better watchmaker. You know, IPA has a lot of appeal for home watchmakers because it's relatively safe to use. It has low odor. It is relatively inexpensive. And if you're using alternatives to professional grade cleaners, it also displaces water, which prevents corrosion. Now, just so you know, when I refer to the use of IPA, I'm talking about anything that's 99% pure or above. I'm not talking about the watered down versions like 70% IPA or even 91%. Now, for the testing today, I'm going to be using all vintage, new old stock pallet forks that are from the same manufacturer, with the same amount of shellac, and are in basically the same condition. These vintage pallet forks are going to be at least 30 years old and are going to be very typical of what you're going to find in older movements that you might be servicing. The first test is just going to see if cleaning a pallet stone with IPA on a Q-tip causes any problems with the shellac. Now, none of these pallet forks have ever been exposed to IPA, and I'm going to use a different one for each test I do. To try to keep the force that I'll be applying to the stones the same throughout the testing, I'm first going to use an artist brush to see if the stone moves as I move the brush across it. And then I'm going to push on it lightly with a pair of tweezers while the pallet fork is in a vise. And what I'm looking for is I want to see if the stone moves up or down in the slot, which is holding them. So on this pallet fork with no exposure to IPA, you can see that neither the brush nor a slight amount of pressure that's applied with the tweezers causes the stones to move. Now I'm going to use a Q-tip dipped in IPA, and I'm just going to do a little light cleaning on the stones, and then I'm going to test the stones to see if they move at all. Now, after a gentle cleaning with the IPA, the stones appear to still be stable in their slots with no effect on them whatsoever. Now, if you're wondering about the long-term effect of IPA on shellac, once the IPA evaporates, the shellac will go back to its original hardness. Kind of like if you were to melt shellac with heat, and as it cools, it goes back to its original hardness in about 20 or 30 seconds. Now, in the next series of tests, I'm going to start by soaking the pallet stones in IPA, starting for 1 minute, and then I'm going to add 1 additional minute to the soaking time until we get to the point where the shellac fails and the stone moves in the slot. So I'm going to select one of the new pallet forks. I'm going to mount it in a vise, and dip it into the IPA for just 1 minute. As you can see, after 60 seconds of soaking, there doesn't seem to be any visible movement on the pallet stone in the slot, meaning that the shellac hasn't softened enough for the stone to move. As you can see, the brush is not moving the stone, and I'm putting just enough pressure on the stone to cause the pallet fork arm to slightly bend. So let's grab a new pallet fork, and this time we're going to soak it for 2 minutes. After 2 minutes of soaking, the pallet stone still appears to be stable with the brush moving over it, and the shellac is still holding even with light pressure applied with the tweezers. So I would say this is good as well. Now I'm going to grab another pallet fork, and this time we're going to soak it for 3 minutes. After a 3-minute soak, it has passed the brush test, but as you can see, a slight amount of pressure with the tweezers has caused one of the pallet stones to fail and move out of its position in its retaining slot. So from these tests, we have seen that cleaning pallet stones with Q-tips and IPA is totally safe. These tests would also suggest that short periods of soaking shellac parts is also safe, especially if they are handled carefully, allowed to dry, and not banged around. Any exposure over 2 minutes might be enough to cause the shellac to soften to the point that the stone can be moved in its retaining slot, changing its adjustment. Now the question becomes, what happens if you rinse a pallet stone in IPA in a basket cleaning machine with alcohol? 99% IPA is a great final rinse because of its purity, the fact that it displaces water, and that there's no residue left behind. So for the home watchmaker who is not using professional cleaning fluids, this is pretty important information to know. Now, since soaking them for 3 minutes in IPA caused failure, let's just step down to 2 minutes of IPA, which is going to be flowing over the shellac, and let's see how it handles that. With the pallet fork loaded in a basket, the IPA will be washing over the shellac as the basket spins at a fairly fast rate. Since the shellac on the pallet fork is extremely thin, as the IPA flows across the shellac, it's going to start dissolving it very slowly, thinning it until essentially there's nothing left. Kind of like how a rock becomes smooth from sitting in a flowing river. And as you can see, I don't even have to touch the pallet stone because you can plainly see that the stone is coming out of the slot. So clearly you would never want to use IPA as a rinse with any shellac parts in a spinning basket. Now, what about the effects of an ultrasonic machine on the pallet fork? Well, if the shellac failed in 2 minutes in the spin basket, we can expect the same in the ultrasonic machine. But what if we used a professional grade rinse instead? So what I'm going to do is I'm going to use LNR number 3 as the rinse, and I'm going to run it for a typical rinse cycle in an ultrasonic of 5 minutes, and I'm going to use 2 pallet forks in the basket. So if you have seen enough of my videos, you probably already know that I always clean my pallet forks and the balance assemblies separate from all the other parts. This not only enables me to take advantage of using IPA as my final rinse, but the main reason is what I'm about to show you. Ultrasonic machines work because of the tiny bubbles that are exploding on whatever's in the tank, which is what is knocking off the dirt and the grime. But if these bubbles get under the shellac, this is what happens. Even when using a professional grade rinse, as you can clearly see, the pallet stone has come out of the slot, which for most of you means you're going to need to source a new pallet fork, or this is just going to become a part watch. Guys, this is precisely why I recommend not running these vintage parts through any cleaning system, no matter whether it's a basket cleaner or an ultrasonic machine. The chances of the pallet stones separating from the slot is so high, the last thing you want to do is have to start looking to replace the pallet fork, because even if you can find one, it's not always a matter of just dropping it in and having it work like it should. Tolerances in the escapement run in the hundredths of a millimeter. If you get a new pallet fork, it is common for either the guard pin to be a slightly different length or for the pallet stones to be set at slightly different depths, both of which can screw up one of the safety functions of the escapement. If the guard pin is too short, when the watch receives a shock, it can cause the impulse jewel to overbank, which is going to stop the movement. Or if the guard pin is too long, it'll rub on the safety roller, which is going to cause excessive friction, which of course lowers the amplitude. So anything you can do to avoid screwing up the escapement should be practiced at all times. Now, if you want to learn more about escapement adjustments, I'm doing a series of master videos on the escapement checks and adjustments, only available on the Patreon page. Guys, thanks for sticking around to the end. And because there's so much more to learn, I'll see you in the next video.